Hello everyone, today's topic is vector integration, Stokes theorem, Gauss divergence theorem. Continuation the vector analysis. Okay, and today topic is vector integrations. Vector integrations there are three types of integrations: line integrations and surface integral, volume integrations. These are three types of integrations. So line integral means the integration of a vector along this curve, that is a b. This is the curve, is called the line integral. This is the as shown in this figure. Let AB is the curve drawn between two points, that is A and B, in a vector field, that is A. So dl is the small element of this length. Since the small length along this curve AB at a point R. R is the vector, that is small r. So suppose small r is equal to capital R, making an angle of theta, the direction of this dl. Then this is the dl and r angle between theta. So you can write this equation: r dot dl is equal to r dot dl cos theta. So r and dl is the that is angle between the theta. So that's why r dot dl is equal to r dot dl cos theta, dl into r cos theta. So then the volume of r dot dl at any pointing of the curve is equal to the product of the small element of the dl and the component of r dot cos theta of r along the direction of dl. So this value r dot dl for the complete curve of A to B can be obtained by this integral form of the integral of A to B r dot dl, that is equal to A to B integral, this one integral, this is the line integral. So this is the curve line, one this is the line integral A to B curve, that is called the line integral. So A to B r dot dl, that is equal to A to B dl r cos theta. So here r dot dl is equal to dl into r dot cos theta. Can substitute this value. So r dot dl is defining as the line integral of A along this curve A to B. So this is the line integral of this formula. And second one is the surface integral. What is the surface integral? Let us consider one surface area. This is the S, and infinite symbol of the area, that is ds. This is the let us consider S and a surface, and infinite element of this area, that is ds, is considered, and if A is the vector at any point of the mid vector of this element ds in a direction making angle of theta. So let us perpendicular line, that is n cap is the unit vector, is positive normal to the ds. Okay, A dot n cap is equal to A cos theta, that is the angle of theta here. So the integral over the surface of area, so that is surface area A dot ds is equal to surface area A dot n cap into ds. So A and n, that is A dot n cap is equal to A cos theta, that is the angle of between theta. Once again I can repeat, this is the surface area S as an infinite small area, that is ds, is considered, and if the vector A at a midpointing of the element, that is ds element, in a direction of a making, that is in a direction that is perpendicular direction n cap. So n cap and A is the angle between theta. So that you can write A dot n cap is equal to A cos theta. So this is the integral over the overall the surface, that is surface integral of A dot ds is equal to A, what is A dot ds, that is ds is the surface area in a vector A. So A dot ds is equal to surface integral A dot n cap into ds is equal to A dot n cap is equal means that is the angle between theta. So that's why A cos theta into ds, that is the surface area into ds. If defined as the surface integral, or total flux A through the whole surface is the S. This is the surface integral of this formula. Surface integral of A ds is equal to surface integral of A cos theta ds. Okay, this is double integration of this symbol. So and Next one is volume integral. This is the third one of this integral. Okay, and let us consider, that is let us consider one cube. This is x axis, y axis, z axis cube. So x direction and y direction and z directions. This is the let us consider this is a closed surface in a space of enclosing a volume of v. This is volume is the x axis, y axis, z axis. A vector function inside and dv is a small element of the volume, then that is the volume integration of a dv is equal to, so a is the vector, so I into ax plus j into ay plus k into az, that is x axis direction, y z terminus is dx dy dz is the length of this x axis, y axis, z axis. Total volume of this dv equal to dx dy dz. This is called the volume integration of a over the volume of v. So dv is equal to dx dy dz. These three integrals of this useful of this next theorem, Stokes and Gauss divergence theorem. Okay, so this is the line integral and volume integral and surface integral. So I can explain that vector integrations are three types: line integral, surface integral, volume integrals. So what is line integral? Is the single integration, only a to b curve you can write this line integral. So I can write integral of a to b r dl is equal to integration of a to b r cos theta dl. This is the curve a to b, that is the line integral of a along this curve a to b. And next, surface integral. Let us consider surface area of the S, an infinite area is the ds is considered, and if the vector is a at the midpoint of the element of ds in a direction making an angle of theta with the unit positive normal to the ds in this figure. So that is, you can write in this figure surface integral of double integration means surface integral. So surface integral of a ds is equal to surface integral of a dot n cap ds. So a dot n cap means a cos theta d. So you can write surface integral of a ds is equal to surface integral of a cos theta ds. It is the defined as this equation is surface integral. And volume integration, this is also three integrations: x axis direction, y axis and z axis. So that's why this is the volume. Three integrations means volume integrations. A dot dv is equal to volume integrations of the axi plus ayz plus az k into dx dy dz. So x direction, y direction, z direction. This is the volume integration. These integrations used in next theorem, Stokes theorem and Gauss divergence theorem. Next, Stokes theorem. Stokes theorem, this is the statement of Stokes theorem. What is the Stokes theorem statement? Is the line integral of a vector a around any closed curve C is equal to the surface integral of curl A taken over any closed surfaces of which the curve C from the boundary, that is integral of A dl is equal to surface integral of del cross A ds. This is the Stokes theorem. Okay, they can prove the Stokes theorem. Let a vector be the vector field acting on the surface enclosed by the closed curve C. The line integral of vector A along a closed curve is given by, let us consider one curve, that is the C curve. This is, let us consider that small infinite small element, that is dl. So that is the vector of A. So here in this curve you can write this integral of C A dot dl. dl is the vector, is the length of the small element of this curve C. And second, let us consider consider divided in two areas enclosed by this closed curves. So that is, one is C1 and another one is C2. The line integral of the vector A and that is closed curve is the C can be written as, that is integral of A dl is equal to integration of C1 A dl plus integral of C to A dl. This is the line integral. Okay, and you can write single curve, that is curve C, and small element is the dl and a vector A. You can write this equation, line integral of curve C A dl divided in two curves, that is C1 and C2. C1 curve is A to B, then and another one part is C2 curve is the B to A. So, these two closed curves, so C1 and C2, therefore the total line integral of a vector A along this closed curve can be written as integral of A dl is equal to integration of C1 A dl plus C2 A dl. This is A to B and B to A part shown in this figure. You can write C1 curve line integral of A dl and C2 curve, that is line integral of A dl. So, this is the small element also you can write number of small elements, one curve and two curves. So, if the area enclosed the curve C is divided a large number of a small areas. So, ds1 and ds2 and ds2, these are the, this is small areas of the surface areas. So, let us consider C1, C2 curve, C3 curve and C4 curve, and small elements is ds1 and ds2, ds3 and ds4, and large number of these small areas of these curves. So, then this is bounded by this curve C1, C2, C3 as shown in this figure. You can write this integration of this equation, integral of C A dl is equal to summation of line integral of C n into A dot dl. This is more large number of this surface area. So, that is why you can write summation. So, that is C1, C2, C3, that is like that summation means summation of integral of Cn A dl. So, according to this definition of this curve, and integral of A dl is equal to curl A dsn, that is the according to this definition of curl. So, integral of A dl is equal to curl A dsn. So, you can write this equation in above equation, integral of A dl is equal to summation of integration of Cn A dl is equal to summation of curl A dsn, and dsn is the surface area of this case under this consideration. So, ds tends to 0, summation of curl A dsn is equal to surface integral of the curl A ds. Then you can write this equation. This equation is substituting in the above equation, that is fourth equation. Line integral of A dl is equal to surface integral of curl A ds, or curl means that is del cross A, you can write that. This is a proof of this Stokes theorem. You can again explain that this equation simply. So, Stokes theorem is, that is line integral of a vector around any closed curve is equal to the surface integral of the curl of a vector S of this curve of the boundary edges. That is called the Stokes theorem of this theorem. That is the statement of this theorem. So, this is the theorem is proof. You can consider one curve, and that is the C curve, that is the small element of the dl, and a vector field A, that is this curve is of line integral. This closed curve line integral is the integral of C A dl, and another curve, this is divided into two parts, equal two parts. So, that is C1 and C2. So, C1 is the curve A to B, and we have now another curve C2 is the B to A. So, this is two parts divided in curve, that is equal to the line integral of a vector along the closed curve can be written as, that is integral of A dl is equal to integration of C1 A dl plus integral of C2 A dl. So, number of curves you can this like that ds1 area, ds2, c1, c2, c3 is also curves. Areas is the enclosed by these curves. C is divided into a large number of small areas such as ds1 and ds2 and ds3 dash dash dsn, and bounded by this curve c1, c2, c3 up to cn. If the area enclosed by the curve C is divided into a large number of a small area such as ds1, ds2, ds3 and ds4 up to infinity of this curves areas, and bounded by the curves, this is c1, c2, c3, c4 up to cn, as shown in this figure, number of large curves. We can write this equation, integral of a dl is equal to summation of integration of a dl, that is summation means number of curves and up to n equal to 1 to infinity. So, number of large areas, we can write that summation of integral a dl. So, according to the definition of curl, integral of line integral of a dl is equal to curl a into dsn. So, this value is substituting in the above equation. Surface line integral of a dl is equal to summation of integral a dl is equal to, what is the value, that is curl a into dsn, summation you can write. So, line integral of a dl is equal to curl a dsn. So, and again that is dn is the surface area in the case under consideration ds tends to 0, that is summation of curl a dsn is equal to surface integral of s curl a ds. You can write this equation in fourth equation. You can write line integral of a dl is equal to surface integral of curl a ds. What is the curl a means, that is del cross a, curl a or del cross a, you can write like that. So, this is the theorem is Stokes theorem is proved. Okay. So, one line is single curve, that is C, and surface integral means, that is surface integral, this is the surface integration of the curl a ds. Okay. This is the theorem is the Stokes theorem is proved. Okay. According to the Gauss divergence theorem, the surface integral of a vector field A over a closed surface is equal to the volume integration of the divergence of a vector field A over the volume V enclosed by the closed surface, that is equal to volume integration of del dot A into dV. So, that is, this is the surface integral and A is the vector field into ds, that is the area, that is equal to volume integration of divergent of a vector field into dV, that is the volume enclosed by this closed surface. This is the theorem is now proved. Let us consider surface area S of any arbitrary shape, then like that vector field as shown in this vector field A. Here see, this is the x and y z direction, this is the cube, and let us consider that is the vector A and unit vector, that is n cap. This is the angle between A dot n cap is equal to A dot n cos theta. So, small area is the ds, dv. So, that is x axis, y axis and z axis. So, angle of x y z axis, the volume dv is known as the div of A into dv. So, that the total flux coming out of from this entire the volume is given by volume integration of div A into dv. Now, consider a small area of this ds as on this surface S as shown in this figure. Okay. This is the total surface S. Okay. And small area is the ds, and that is the vector A and n cap perpendicular direction, that is the angle between theta. Let n cap is represented the unit vector drawn perpendicular to the ds. In conservation, the total outward drawn normal to the taken as positive x direction. If the field vector A and outward a normal n cap are at the angle, theta is the component of A along this n cap is, you can write A dot n cap is equal to A cos theta. The flux up through the surface element ds is given by A into n cap ds is equal to A dot ds. So, that the total flux through the entire surface S is given by surface integral of A ds. They must be equal to the total flux dividing from the whole volume V enclosed by the surface S. Hence, from this equation 1 and 2, the surface integral of A ds is equal to volume divergent of A dV. So, that is you can, this is the theorem is Gauss divergence theorem. Surface integral of a vector field in closed surface is equal to the volume integration of divergent of a vector field into that is enclosed of this volume. That is the proof of this Gauss divergence theorem. This is, you can write div A means del dot A. You can write del dot A. Surface integral of A ds is equal to volume integration of del dot A into dV. These problems divergent and curl of a modal problem. If pi of x comma y comma z is equal to 3x square y minus y square y cube into z square, find the del dot pi at the point of 1 comma minus 2 comma minus 1. Del dot pi is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. That is pi value is the 3x square y minus y cube z square. So, I term into, that is the pi value, I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. So, you can partial differentiating with respect to x, y and z. So, that is del pi is equal to with respect to x, 3x square y means 6x y I minus that is, this term is no x term. So, that is why this is the value is 0 plus j and dou by dou y, that is the with respect to y in partial differentiating 3y x square y means that is 3x square and minus y cube z square. Y cube z square means with respect to y that is y cube means 3y square into z square. Here only 3x square term with respect to y, that is 3x square only partial differentiating with respect to y. So, that is why that is the dou y by dou y is the 1, 3x square minus 3y square into z square is the constant, and again with respect to partial differentiating z. So, 3x square y means here no z term, that is the 0, and y cube into z square, y cube is the constant and z square means 2z. So, minus 2z y cube k term. So, that is 6xy I plus 3x square minus 3y square z square into z minus 2y cube z k. You can write the coordinate points 1 minus 2 minus 1. X is the 1 and y is the minus 2 and z equal to minus 1. You can write x term and y term and z term. Then this value is substituting x, y, z values. You can finally minus 12 I minus 9j minus 16 k. That is the grad pi or del pi value. And one more another problem, divergent of A. So, A is equal to x square z I minus 2y cube z square j plus 2xy square z k. Find del dot A or divergent of A at the point of 1 minus 1 1. You can write what is the del dot A. Del means I into dou by dou x plus j into dou by dou y plus k into dou by dou z into what is the vector A, x square z I minus 2y square z 2 y cube z square j plus x y square z into k. So, that is I term, that is I term, I into I is the 1, I into I dot j is 0, I dot k is also terms 0. So, only I dot I equal to 1, j dot j equal to 1 and k dot k equal to 1. You can multiply in these two terms dou by dou x in, that is I term, the I term means that is x square z plus dou by dou y into y, j into j, that is 1 minus 2 y cube z square plus dou by dou z x y square z. So, this is the partial differentiating with respect to x, y, z. So, here that is x term, x square means 2x, that is z is the constant, minus 2 y cube, that is 6 y square into z square is constant, plus x y square means y square x y square is constant with respect to z. So, that is z is the 1. So you can write 2xz minus 6y square z square plus x y square. This is the divergent of A. Substituting the x y z points 1 minus 1 1, you can write x y z values. Simplification of that value of del dot A is equal to minus 3. That is the divergent of A value. So this is the line integration, volume integrations, and Gauss divergence theorem. Stokes theorem is the very important, that is related to the vector integrations, surface integral, line integral, and volume integrations. Use this theorems, Stokes and Gauss theorems. So that is the divergent and curl and divergent, grad, curl also use these theorems.